Hi, welcome back to Moose and Chemistry. This is electromagnetic spectrum problem number 3. Let's look at the problem. What is the wavelength of a photon that has a frequency of 2.0 times 10 to the 14 hertz? Answer in nanometers and determine what type of radiation this is. Okay, we need to know C equals lambda V formula. We need to know that C is the speed of light. We need to know that the speed of light is either 3.0 times 10 to the 8 meters per second, or you could use 2.99 times 10 to the 8 meters per second. That lambda is wavelength and V is frequency. Okay, so let's go ahead and put in our original formula. C equals lambda V. And we're trying to find wavelength, so we're going to isolate for lambda. So lambda equals C over V. Pretty simple. Now let's go ahead and put our numbers in. So lambda equals the speed of light, which is 3.0 times 10 to the 8 meters per second, right? Divided by our frequency, which happens to be 2.0 times 10 to the 14 hertz. Now it's in hertz, so I'm going to do 1 over s minus 1. Because that's what I can do. So now my s minus 1s will cancel my s, and our lambda value, come back up here to the top, lambda is going to equal 1.43 times negative 6 meters. Pretty darn snarly, eh? But we didn't want it in meters, we wanted it in nanometers. So we got to convert meters into nanometers now. So we take 1.43 times 10 to the negative 6 meters, and we're going to convert this baby into nanometers, right? And we're going to go, all right. In 1 meter, there are approximately 1.0 times 10 to the 9th nanometers. Okay, when we get that, our new wavelength in nanometers is going to be 1,430 nanometers. Well, if you look up here, I've got this in nanometers and micrometers and meters. So we need to see what 1,430 nanometers equals to, because it's going to go into the micrometer area. So we're going to convert that. So we're going to go 1,430 nanometers times 1 micrometer divided by 1,000 nanometers. So there are 1,000 nanometers and 1 micrometer, right? This is going to give me the answer of 1.43 micrometers. Okay. So our original answer is going to be this, 1,430 nanometers. But when we use the scale right here, we need to know what it is in micrometers. And it happens to fall right about here. I'm going to put an X there. Falls right about there. And that's in the infrared area, guys. So this is going to be IR radiation. Okay? And that's it for this lesson. You guys be snarly, and we'll see you back here at Moose and Chemistry.